Let's take a look at reflections of functions. When you look in a mirror, you see a reflection of yourself. In that reflected image, the right and the left side are reversed. A similar thing happens to a graph when it is reflected. There are two types of reflection that we'll be studying: reflection in the x-axis and reflection in the y-axis. To reflect a graph in the y-axis, we change the signs of the x-coordinates of all the points on the graph. Positive x-coordinates become negative, negative x-coordinates become positive. The y-coordinates stay the same. And we can see in this picture, if the point 1, 5 is plotted, then if we reflect it across the y-axis, the point -1, 5 is its reflection. The idea is we have the same distance away from the y-axis for both points. Notice that the height did not change. So that's why the x-coordinates change sign, but the y-coordinates stay the same. The heights are the same, the y's, but the x has been flipped across that y-axis. So let's practice with this. We'll start with points and then we'll look at lines. So first we can label each point with its coordinates, then plot the reflection in the x-axis of each point and label the reflected points with the appropriate coordinates. I'll do 2 of these together with you, and then I want you to try the other 2 on your own. Let's start with this far one on the right. We're at 4 on the x-axis and 1 on the y-axis, so that ordered pair is 4, 1. If I reflect this across the y-axis, then my y value stays the same, but my x-coordinate changes to be negative. -4, 1. And I'm going to highlight this one too so that we can see the reflection pairs. Looking at one more, let's take this one down here in the bottom left corner. We have the ordered pair on the x-axis, a -2, on the y-axis, a -1. So the ordered pair is -2, -1. If I reflect that across the y-axis, the height stays the same, but the x-coordinate changes sign. At this point, you pause the video and try the last 2, and when you resume, I'll have the answers. And notice for the upper one, notice the upper point, the one I've highlighted in blue, I have the ordered pair -3, 2. Its reflection is the point 3, 2. And the very last one, the pink pair, 2, -3 was the original one, and its reflection across the y-axis is -2, -3. If we take this graph and we fold it along the y-axis, these points will match up. That's what a reflection means. For lines, we're going to look at the end points of the lines. We'll take the end points here, label them. So we have -1, 4, 3, 1, and -2, -4. And we'll play this same game, reflecting across the y-axis by changing the x-coordinate only to create a new graph. -1, 4 becomes +1, 4. 3, 1 will become -3, 1. Remember, the x-coordinate is the only one that changes. And then -2, 4 becomes +2, -4. Once we have completed the endpoints, then to recreate the graph of the lines, we would connect the dots. So we're going to make sure that the same points that are connected in the original, their reflections get connected in the reflected graph. And there we have our reflected graph. One more thing to point out, the graph and its reflection are going to touch or intersect on the y-axis. If I have a point on the y-axis, the x-coordinate is 0, which has no sign. So if I change the sign of the x-coordinate, 0 stays at 0. And then to reflect a shape, we'll use exactly the same process as we did for the lines to reflect the shape. So try this one on your own, pause the video, and when you resume, I'll have the solution for you to check. Remember, if you make a mistake, it's okay. Correct your mistake, maybe with a different color, so that you can see what you did wrong. Make a note of it and learn from that mistake. Don't just erase it. And the same goes with your homework. Don't just erase your homework. Keep that mistake there, make a note of it, and redo the problem below so you have a record of what you've done, why it was a mistake, and that you're correcting it. That's how we learn from our mistakes. Now, does your shape look like this one? Great. This is how we reflect in the y-axis. Right now, we're just practicing with this idea. We are going to look at how this affects our symbolic representation of the function soon. But let's continue with this practicing. Let's look at one more graph. This time we're reflecting a function. And although we're going to talk about families of functions, this particular graph is that of a quadratic function. It's called a parabola, and we're going to be learning a lot about parabolas this semester. They have a lot of applications in the real world. We're going to play the same game that we did in the previous problems, where we identify the coordinates of the points and then reflect them across the y-axis. Try this entire problem on your own. Pause the video, see if you can reflect the graph, resume, and check your work. And there's our reflection for our parabola. In this case, notice that the graph is curved, not with straight lines. So we want to make sure that we're careful when we redraw this reflection that it's also curved.